Okay, today I'm going to show how to compute the LPS table for the KMP algorithm. So, compute LPS table. What is LPS table? The LPS table is the longest prefix, which is also a suffix. Longest proper prefix, which is also a proper suffix. Now, what are proper prefix and proper suffix? Suppose you are given a string A. What are the proper prefixes? The proper prefixes are the prefixes of the string which are not the string itself. So A is a proper prefix, AA is a proper prefix, AAB is a proper prefix, but AABA is not a proper prefix. Similarly, what is a proper suffix? The proper suffixes are the suffixes of a string which are not the string itself. So A is a proper suffix, BA is a proper suffix, and ABA is a proper suffix. So if you want to compute the LPS table for the string AABA, what it should look like. So the LPS for the LPS table, let's write it like this, okay? So so at so it's a single dimensional array. So the zeroth position, right? We need to find that at the zeroth index, what is the length of the longest proper prefix, which is also a suffix. So at this position, we don't have any proper prefix or proper suffix that matches. So that's 0. Now at the index 1, what is the length of longest proper prefix at which is also proper suffix? So at index 1 at this position, if you look at the suffix, right? What is a suffix? What is the proper suffix that we have at index 1? So at index 1, the proper suffix that we have is a, and the proper prefix that we have is a. So the length of the longest proper prefix, which is also a suffix, is 1. Because look at this. This is a suffix, this is a prefix. Both of them matches, the length is 1. Now at index 2, what are the proper suffixes and proper prefixes? So at index 2, the proper prefix are AA. And what are the proper suffixes? It's B and AB. Do we have any match? No. So at index 1, it's 0. Now at index 2, it's 0. Now at index 3, what are the proper prefix and proper suffix? At index 3, the proper suffix are A, then we have BA, and we have ABA. And what are the proper prefixes? We have AA, B. So the longest match that we have between the proper prefix and the proper suffix is 1. So at index 3, the longest match that we have is 1. Let's take another example. Okay, let's take next example. The next example is A, A, A. So here, what are the proper prefix and proper suffix? None. So it's 0. No match. At index 1, yeah, we have AA, which matches, so 1. At index 2, the proper suffix, the longest proper suffix is AA, and the prefix is AAA. So let's write it here at index 2. The proper, so at index 2, the proper prefix are AA, and the proper suffix are AAA. So the maximum match that we have is 2. At index 3, we have 3, which is the maximum match. So for example, let's do this. Okay. So for example, for I is equal to 3, we have proper prefix as a, and the proper suffix a. So the maximum match we have is 3. Let's take another example. So in this example, we are going to take A, B, B, A, P. So at index 0, there are no proper prefix and suffix. So 1. At index 1, what we have? What are the proper prefix and suffix? Let's do this again. Okay. So at index 1, at I is equal to 1, the proper prefix are A and the proper suffix is B. No match. So 0. At index 2, I is equal to 2. The proper prefix are AB, and the proper suffix are ABA. There's a match which is of size 1. At index 2, at index 3, the proper prefix are ABA, and the suffix are BAB, and there is a match of size 2, AB. So that's how you compute the LPS table, and it's useful for the KMP algorithm. For the KMP algorithm, we compute this LPS table for the pattern, and then that's how we reduce the time complexity of the KMP algorithm. Now let's go into the implementation detail, how we compute the LPS table. So to compute the LPS table, let's say you are given public void compute LPS table. You store the LPS, you compute the LPS table in an array LPS and string pattern that's given. So how you compute? So what you do to compute the LPS table is you iterate through this pattern, and so this for the index 0, the length of proper prefix, which is also a suffix, proper suffix, is always 0. So initially the array elements are all 0 default. So the 0th position is 0. Now we'll start from I is equal to 1, right? And then let's I guess let me help you to trace this, and then we'll go into the implementation detail. Okay, so what we are going to do, let's take a very long string. Okay, something like A B A C B A C A A B D C. Okay, so we know that the longest prefix, which is also a suffix, proper suffix, is 0 at index 0. So now we'll start from 1. Okay, so our I is here. Okay, and let's say the j is pointing to the this 0th index. So j is here, and we see whether the character at I matches the character at j. If it matches, right, that means we already had a we already have this much length of prefix and the suffix that we're matching here. So if this matches the character at I and j, they matches, then it's one more character that's matched. So we should increment this by 1. So 0 plus 1, 1. Now, after that, you increment I and it goes to the next index position B. And then you initialize J again with this LPS of I minus 1, which is 1. So what is the LPS of 1, which will still be here? So J will be here. Now this two don't match. If this two don't match, we have to move to the last prefix boundary where it matched. So what we are going to do is we are going to move J to LPS of J minus 1, right? So J will be moved here. Now this two also doesn't match and J became 0. So now we are going to increment the I and then we're going to initialize the J. We are going to initialize the J with this LPS of I minus 1. So J is here. LPS of I minus 1 is 0. So J should be pointing to the 0th element. Now we compare this A with A. It matches. When it matches, then we should add 1 because we matched one character. So whatever we have here, right, we have 0 here. So 0 plus 1, 1. So this will be 1. And then you increment the I. Then you initialize the J again to LPS of I minus 1. What is LPS of I minus 1? 1. So J should go to here. Now you match A and C. They don't match. If they don't match, then you move J back to the last prefix boundary that match. So J should go to LPS of J minus 1, right? So what is J minus 1? LPS of J minus 1, 0. So J will go here. No, still no match. So now J became 0. So let's increment the I and see. We see, oh, there is a match. I and J matches. So we till here we have 0 match. So 0. Now we match the one character. Let's make this 0. And so 0 plus 1. So there is a 1 match. So one longest proper prefix, which is also a suffix of length, 1 match at this point. And then we we initialize LPS of I with whatever the value of J we had plus 1. Now we increment the I. Again we initialize J with LPS of I minus 1, which is 1 minus 1, which is LPS of 0. Sorry, 1 I minus LPS of I minus 1. And LPS of I minus 1 is 1. So J will be here at index position 1. And now we are going to match A and A. They both match. So we need to set LPS of I to J plus 1, which is 2. So we have this AA matched, so longest proper prefix, which is also a suffix. So AA matched here. Now we are going to increment I and we are going to initialize J with LPS of I minus 1, which is 2. So J will be here. And we are going to match B and B matched. So LPS of I will be J plus 1. J is 2. 2 plus 1, 3. We increment I and we initialize J to LPS of I minus 1, which is 3. So J will be here. There is no match. Since there is no match, we move back J to the last prefix boundary that match. So we move J to LPS of J minus 1. What is LPS of J minus 1? 0. So we move J here 0 and we see that j became 0. So we increment I, and we initialize j again with LPS of I minus 1, which is 0. J is already at the 0th position, so we increment I and we are done. So that's how we are going to do that. Okay. So what we are going to do is this outer for loop. Okay. This outer for loop. This outer for loop is for the pattern. Okay. So integer I is equal to 1 because the 0th index will always have 0. I less than pattern dot length I plus plus. Okay. Now integer initialize j. So j will be LPS of I minus 1. That is, we are updating the prefix boundary. Here we are updating the prefix boundary. Once you initialize the j, so if there is no match, right, then you move j back to the last prefix boundary match. So if there is no match, move j to the last prefix boundary match. So while j is greater than 0 and pattern dot character at I not equal to pattern dot character at j. So let me do this. So that's the while loop, so that just you can see. Okay. I hope that's visible. Okay. So while it doesn't match. Oh, I already had the curly brace. Okay. While it doesn't match, move j back. So j will be equal to LPS of j minus 1. So j will be moved back. So it would be LPS of j minus 1. And then if there is a match, if there is a match, that is, if prefix boundary matches the suffix boundary, then what you do? Then you just increase the prefix length, right? Then you increase the prefix length. So if pattern dot character at I is equal to pattern dot character at j, that means you matched one character, so whatever the previous value was, so LPS of I, whatever the previous, you match the previous thing, the previous prefix plus 1, so j plus 1. And that closes the for loop, and that closes the main function, and that's it. That's the code for computing the LPS table. So if you look at it, it's very simple. You just try to find, if there is a match, then it should be whatever you have matched plus 1, so j plus 1, right? And if there is no match, then you keep moving j backward till the last prefix boundary match and try to see if there is a match. So this way you can get the longest proper prefix, which is also proper suffix table computed. So this way you can get the LPS table computed. and yeah, and the time complexity for computing the LPS table is whatever the length of this pattern is. So the time complexity is the length of the pattern. Suppose the length of the pattern is m, then the time complexity will be m, O of m. So that's the time complexity for computing the LPS table. So in the next video, I'll cover the KMP algorithm. Uh, I'll not cover computing the LPS table. I have already covered it here. I'll just go over it very briefly. Um, so you can refer to my next video for the KMP algorithm.